Good morning, good afternoon, or good evening, depending upon where you live around the world. Yes, indeed, I can well imagine people are going, "Oh my goodness, what has David done here?" Well, what David has done here is develop the tabbed plates a little bit for good and bad reasons. Well, not bad, but for good or gooder reasons. Yeah, I know. Perfect English. The tabs are in the format now that you see for the model that we've been working on. As you know, I've been flip-flopping back between tabbed plates or the steel tubular hubs with threaded rods, etc. I did say this is probably 60-40 chance of being made or higher, 70-30, pick a figure. But I've developed them up again, redrawn them, and I've kept some of the drawings like this so that we have choices later on, because my choice may not be the final one that I go with. I'm alluding to this line of drawings up here, and it may be these ones that I require. So these are the hubs of the dome. The bottom hub here, this is the very top hub, and like I'll talk about those. The left and right hubs near, at the bottom of the legs or the top of the legs, etc. They have been drawn pretty basic. They've got a 57mm plate in the middle. Why 57? Well, it is the size of a tube that I'm able to get here locally, and therefore, on the off chance that I want to use this in conjunction with the tube, this one here in fact, to the right, then I can, because it would be the same dimension that I'm using to make the model. There is a possibility that a tube, not in the normal sense of it when I'm talking about the steel tubular hub, but the tube may well be used in conjunction with the plates themselves. So I'm allowing for this in the modelling. Yippee. I have bent these ones are already bent into the tabs, that is, into their correct orientation, and are ready to go to be reinserted into the model itself. So this will be a continuation of the total redraw, because it builds upon the model and is a, total redraw. This line here was going to be a model pretty much like this one, where I've bent the tabs, but still only in 2D, bent the tabs down. Thinking about deleting that line and just retaining the information like this. A couple of missing there. And this is the plate that is 57mm in radius. If I said diameter before, I meant radius. So it's 114mm in diameter for the reasons that I said. And the tabs are flat, because it may be that you want to, photocopy these and get them printed out or whatever, or print them out, be the thing, onto an A3 sheet. You may need to take the file down, which will be made available at some stage in the future, maybe, or your own drawings. But if you want to have this printed out, you could use the printout as your template. Take it out to the shed, etch it, scratch it onto the metal sheet that you're wanting to use. This one here, however, is a significant, I think, improvement. It has done away with all the excess metal, which isn't required. It simply is not required. There is no less strength, says I, hesitantly, in this one to this one. Or put it this way, there's not much less strength, if any, in this position here, where it folds. It is the same cross-sectional area, so therefore they are comparable. Through here, there is a possibility that it's not as strong because the material is reduced, but otherwise the area of connection for the tabs to the plate remains the same. And all I've done is I've made a tangential arc to take away that material. But for the important feature of, if I was running a bandsaw or a jigsaw with a metal cutting blade, it would be much easier just to continue along this line and swoop down and cut the metal. Making these internal changes in direction would be a bit tricky, and you'd have to wind up doing some sort of transition from plate to tab anyway. It also has the feature of perhaps reducing stress-induced fractures. I can't see why that would ever be a reason for concern in this sort of plate, because it's not really going through cycling of, like tension and compression or stretching or whatever. It's just not that sort of plate, it's just not. That it may have those at some degree, well, as I keep on using that hackney old comment now, I'm not an engineer, and they would be able to assign a figure to that. The only one that was a problem was this one here. I couldn't get a radius in there because the drawing program says it's too tight to get a radius in there, but otherwise they're all of a different diameter, you could say, and as I said, they're just a tangential arc created within the program. Ditto here, a lot of the material has been removed because it really doesn't need to be there. It serves no worthwhile purpose. If I was to combine these with the tube, would it work or not? Don't know, but that's why I've left the information here in the model. So if I have to go back to this, I can. Now, what have I done here? Well, I'm pleased you asked. If you have been following at all, you may know that there are a couple of joints in the model that I have some real world concern about. Sorry for that whistle. I can't get rid of my teeth. And they're all mine. What are left. Okay, so this is one of the joints that may require a little bit more beefing up. So, I have said right from the get-go that I'd more than likely have most, if not all, of the joints with a plate top and bottom. Stabilizes it. It's effectively it's not quite like it, but a double shear situation. But it actually stabilizes the joint and increases the strength a lot. Apparently, it more than doubles the strength by having this extra plate on top. But to me, it just makes sense. What I've shown down here is a stacked plate. Still 3mm, if that's what we go with, but because we want more strength in the particular hub and strut connection area, why not just put two of them in there? Bolt them together in the middle, mainly for registration, drill the hole in one process so that they align perfectly, put your bolt through, you're done. Or, here we go, if you want to be crazy and bolt through excuse me, the bottom plate or plates through to the top one, which is a jolly good idea, you will need to have some change in the top tab. It has to be at least 25mm longer to allow, or thereabouts, to allow you to have metal to have a hole drilled into. So my recommendation or my thoughts are, hey, let's just make these 3mm plates. Don't drill them. Leave them blank, and upon the decision of where they're going to be inserted and how they're used, i.e. stacked, then we can draw, measure, what have you, the position for the holes. It's a rational design in that the tab, all of the tabs for all of the struts, the hubs are the same. It is from the bend point down, it is 150mm long, much longer than some of the other plates of similar design. The Star plate by Viking Domes and the, cursed, whatever it is, cast, star plate type things. They're much longer. They're not as thick as some of them, but thicker than others. So it's like some engineer has, or builder like me, have just guessed at it, but well, engineers calculated. Ooh, didn't mean to insult the engineers, but if we want to, we can make these tabs as long as or as short as we want. These are almost 50% longer than some, but it is what it is. This is, I think, more versatile, maybe. But anyway, the holes would be 25 millimeters back from the bottom edge, and then 100 mils there, so 125 mil. 25 mils in from each end, you could say. When they're stacked, there is some misalignment, so don't pre-drill them and try to stack them on top of each other. Excuse me again. But with those common measurements, we can then generate our model and adjust the model accordingly. Could we shorten the bottom tabs to allow yes, we could. Anything that you want to do. It's just where the strut comes in here. If we angle the strut or keep it square, lots of design criteria requirements. If we keep the end of the struts angled, then the point of where we angle the plate and the strut, that's your registration point. It is there, and it is pretty much within a mil at this point here. So that alone is a good way to register your plates. Or we just drill accurately based upon our measurements from the model. And we'll get into that at some stage in the future. If you want to go even further, for what reason I don't know, but you could draw this back, and by insert it into the model, it's very possible that we create a situation where the tubular hub, a tube is inserted into this particular style of hub. Why? Well, this way, let's just adulterate this a little bit. Comes up to there. The plates themselves are now working in conjunction with the tube. Great. Could they be bolted or welded together? Yes. Would I? No. Why? Because it involves welding. Well, that's for one reason. And bolting it, I don't see the advantage. But what it does is allows the struts to push up against the tube. That allows, again, back to that hackneyed old comment that I'm not an engineer, but it allows the pressures, forces, loads that are being exerted on the dome, they run through the struts and onto, into, or through the tube itself, the steel tube. And therefore, some of the strength or stability of the structure is being helped by the tube's presence. It takes the demand or loads off of the fixings and the plates themselves. I'm not an engineer, but that's a reasonable assumption to make. Is it beneficial to have that additional component? I can't quantify it, so therefore I can't say, but I can see in my mind, just a builder, that it has an advantage that with it not there, won't be there. Not having it there, I don't think for what we're contemplating is going to be that much of a downside, because this is going to be a super strong hub. Stabilised top and bottom, well, that's a tick. Double thickness there, that's a tick. You could put double thickness top and bottom. Okay, just keep on going until you've actually made a solid steel. I'm just exaggerating it. I'm over-egging it. But it becomes a very stable joint. And this is not the joint I'd be concerned about. It's actually this one. Just saying. But it's not going to be difficult to get your head round that this is a strong joint and potential strengthening of it. It's easily done using shop-based tools, like a woodworking shop-based tools. So yeah, I quite like this approach. And again, as I said in the other videos, it's probably taken that 60-40 or 70-30 slot in my thinking of which one would I go with. Could I make a combination? I could do anything I want. I could make it out of tinfoil. It just wouldn't be very safe. I could do what I want. This is the opposite of tinfoil, of course. I know. I'm just chewing the fat. But yeah, it's quite easy. We move on from here to figuring out just where we want, and I'll bring in another model. Here, I'll do some hiding. Where we want the sockets, or how we want the sockets that the holes to be formed. And in this case, we've just got a threaded rod or a bolt coming up, nut and washer bolted down, of course. And I've just represented the bolt by a nut and washer here. I think I'd probably going with a what you call it, a thingy-bob, a coach bolt, one with the round head. That would look quite good. If you're having underbattens on, which is a possibility, not probability, but you could hide whatever you put there, so it doesn't really matter. Some of the head could be embedded in the underbatten, depending on the size of the underbatten, should you want to use one. So there's that. Not going to do too much in the way of modelling of that, because there's a lot, but certainly this joint and this joint up here, probably 3 joints in total. This one here, here and here, they are the busiest and more... This is the easiest because it's only got 3 struts coming into it. This is the hardest because the angle of the struts make it very tight in here. And this is the busiest because it's got 8 struts coming into it. The plates are a little bit different if I make the, like that radius. So it's just going to be interesting. Anyway, there we go. We will go back to this drawing. So that's where we're at. A wee bit of thought has been done. It is now going to be titled like Total Redraw number 5, because it has progressed the model along one more step. The next video is more than likely me having these put back into the model, which is a little bit of a job, and or I'll show how I get to drawing this plate in the, like I have here. Not rocket science, very easy. Oh, that was one of the thoughts. And it justifies making this little model, because it was this model that I used to make these plates. And real easy. And no, you didn't have to worry about the angles or the measurements. They are for another day. So, there we go. Yeah, I think that's quite a thorough covering of where we're at the moment. Like the idea of cutting away the excess material. Makes life easier. I think it looks a little bit neater, actually. Wouldn't be necessary if we had it laser cut, like by machine. But I don't have an expensive laser cutter. I don't want to send these off to be laser cut. There would be numerous versions of them, so I just don't want to do that. I'm not doing this commercially, so could I? Oh. I see some local companies in not in Christchurch, in Wanaka, which is south of where I live. They've got star plate type fixing, so interesting. Good on them. And they are doing it commercially, so well done. If I had a laser machine in my workshop, maybe. Maybe not. Hey, I'm doing it because I'm enjoying it. Right, that's it. With that, I'm off, and I will see you hopefully in the next video. Okay, we'll see you later now. Bye.